quick graph one period of y equals 5/2 times the cosine of the quantity pi over 3x plus pi minus 1 by hand. This is part of the family of functions series. You will need paper and straight edge, and we suggest you create grids similar to the ones at the right as needed, and press pause as needed anytime during the video. So we're going to graph one period here. We'll start off by analyzing the equation and the parameters. Which parameters affect y values? We'll start with those first. And in this case, they're the ones outside the function, 5/2 times and minus 1. So 5/2 times multiplies each y value by 5/2. Minus 1 subtracts 1 from each y value. And by the order of operations, remember we multiply first, subtract second. Let's look at the y values of the points of interest. We're going to multiply 5/2 times the y value, then subtract 1. So the maximum normally is at y equals 1. So we're going to multiply that by 5/2 and subtract 1. So that'll be 5/2 minus 2/2 for 1, which is 3/2. That's where the maximum will be. Point of inflections normally are along the line y equals 0. But if we multiply 0 by 5/2 and subtract 1, we get -1. The minimum normally is at y equals -1, but we're multiplying that by 5/2 and subtracting 1. So we're going to get -5/2 minus 2 more halves is -7/2. And so here we're color coordinating them so you can see them, and we'll also summarize them over here. So pause is needed, resume when you're ready. Which parameters affect the x values? Those are the ones inside the argument. The beginning of a period normally starts when the argument is equal to 0. So we're going to set that argument equal to 0 and solve for x to see where this period starts. So pi over 3 times x plus pi equals 0. Solve that. Resume when you're ready. Multiplying each side by 3, each term by 3, and then subtracting 3 pi from each side. And then finally dividing each side by pi, we get x equals -3. And notice that it's -3, not -3 pi, not in terms of pi, it's just -3. So this graph will begin at a max at x equals -3. The end of the period normally ends when the argument is equal to 2 pi, so we'll set that entire argument equal to 2 pi and solve for x. Pause is needed, resume when you're ready. Multiplying again each side by 3, each term, and then subtracting 3 pi from each side, and dividing each side by pi gives us x equals 3. Again, not 3 pi, just plain old everyday 3. And so the period is going to end, the first wave will end at x equals 3. Pause is needed. So we're going to use all these values below to decide how to mark the units on the axes. So we're going to suggest marking every 1 unit on the x-axis from -4 to +4, just to give ourselves some room on each end of the period. And we could mark off either 1 unit or half unit on the y-axis. And we're going to say go from y equals -4 to y equals +2. Pause to create those pairs of axes, and then resume when you're ready to check. So here, -4 to 4 along the x-axis. On the y-axis, we went from -4 up to +2. And we showed each half unit there on the y-axis. So let's put all of this information together kind of like a puzzle. I'm going to draw dotted horizontal lines at the maximum, the point of inflection, and the minimum, and I'm going to color coordinate them so you can see them easier. So y equals 3/2 is our max. Y equals -1 is where the points of inflection will be. And y equals -3, 3.5, -7/2 will be where the minimum is. So recall the graph of one wave of the cosine. We start at a maximum, normally at 0, 1. But for ours, we're going to start when x equals -3, and the maximum is 3/2. So we're going to plot -3, 3/2. The end of the period, normally 2 pi away. In this case, it's going to be at x equals 3 is where we'll start. And the maximum, again, is still 3/2. So 3, 3/2. Halfway between those two maximum points is the minimum point. And so halfway between -3 and +3 is x equals 0. And the minimum value is -3.5, -7/2. So we'll go ahead and plot that point. Halfway between a max and a min is a point of inflection. So that's going to be at -1.5 down to -1, where the points of inflection are. So we'll plot that. And similarly, between the min and the max is another point of inflection, halfway between at +1.5, -1. Pause is needed. Connect the points as a cosine wave, frown or concave down, smile concave up, frown concave down, and let's make it look really nice. I should point out equivalent forms to our equation. We could factor out pi/2 inside, pi/3 inside the argument. And from that, we can see that the phase shift will be left 3. And we can see that was the case here. Left 3 is where we started the cosine function. And the period is affected inversely by this coefficient. So we're going to divide by pi/3 or multiply by its reciprocal. And when we do that, we get a period of 6. And from max to max, -3 to +3, the period is 6. So that double checks as well. So pause if you need to. Now you try one. Graph one period of this cosine function here. A hint, you're going to need to change the units once you decide to do this. You need to do a lot of analyzing before you start to graph this. So pause is needed. Resume when you're ready to see the answer. And so here is our graph, color-coded, so you can see the max, points of inflection, and so on, how we got the beginning of the period, the end of the period. Okay, so study that, and that's the end of the video.